Hi everyone, welcome to Mom to Machinist. This is our third installment. In this video, Riaan is going to show me how the machine works, the actual machine. In our previous two videos, you saw me first design the component. In the previous video that came out, I showed you how I basically use SOLIDWORKS CAM to create the program that's going to cut the block, the metal, out. So in today's video, Riaan is going to teach me how the machines work. Riaan, thank you very much. We are actually currently at the Doosan Marketing Workshop. AMP is part of the Doosan family, so we're at home. So thank you, Riaan.
It's my pleasure. So today's idea is actually just to show Alrieke how to operate the machine, and to make sure that before she actually starts machining her parts from the CAM software from SOLIDWORKS, they actually know how to operate the machine and actually how to set up the entire machine for the part itself. Cool. So when it comes to machining, you get two different. Majority of the time, you get Heidenheim, Fanuc, Siemens, that type of control panels, and obviously ours as well. Currently, we only are familiar in our own workshop with Fanuc and with Siemens. Majority of our VMC milling machines, so we use Fanuc. We do have one Haas machine operating system, and then on our turning side, we also have Fanuc control panels. Okay. So the main thing when it comes to setup is to make sure that your setup is 100% accurate. To make sure that when it comes to machining, that your setup won't fail yourself. Okay. So the main thing is when it comes to setup is to make sure that your bed is 100% clean, and then your fixtures, visors or chucks are 100% clean and accurate to your setup. Okay.
Okay, so we've started cutting the tool, or the block, not the tool. We've started cutting the block using the different tools. In our program, there are different operations. First, we phased off the top part just to get it nice and clean. Then we went in rounding the quarters, and then we started actually phasing out the outer edge or the outside of our stock. We have cut down to size, and we are currently busy. The process that's currently running is we're cutting out the inside pocket part of our block. So that's the part we're busy with now. I think it's interesting to go through the process from design to actually making it. I have learned quite a lot today, specifically with regards to the in-between step. So what's nice to know for me is the program that we are using today is a program that I created a while back, and we made a small few changes. One was, like I mentioned earlier, we made sure that all the tools that we have or that we're going to use is in the right order. Then Riaan did something as a safety step for us, for me, for learning. And that is he entered a forced stop. So after each operation, we're stopping, having a look what it looks like before we start again. So that's another thing we added. And then of course making the changes to the stock. But then taking that, plugging it in and running it, it's nice to know that that's the stuff that I've created. Cool. So one of the things that we need to keep in mind, and that's why we can't just leave the machine, is we need to keep our eye on the program. The program gives us a bunch of numbers and things. Basically, it's just the actual code that's the program is using to cut the material for us. Now we need to keep our eye over here on any G0s with a Z minus after it. G0 means it's cutting at a rapid pace. And if we cut too fast in the Z minus direction, it could cause a problem on the material, especially if it's not something that we want in our program. It shouldn't be in there, but it's always something we need to keep an eye out for. So we want to make sure that there are no G0s, which is just the G0, and a -Z. -Z means we're cutting towards the material, plus Z means we're moving away from the material, so we'd rather move away from the material at a rapid speed instead of going towards the material, because that could hurt our material, it could hurt our tool. A bunch of stuff can go wrong, so we just keep an eye to make sure that any of those things aren't in there. If there is anything like that showing up, we turn down the speed, the spindle speed, so that we can actually see what's happening. Currently our rapids is actually turned off. We're not cutting at a rapid pace at all. That's just an FYI. Another thing I'm learning. I'm so happy. Okay, so what we did was we just removed this portion with the last set of code that we've written. It actually finished it off quite nicely. There's no grooves, nothing. Then we just went over with a file to create a simple chamfer. I'm extremely excited. I'm so happy. It's nice to be able to say that I made this and I did most of the machining. So yeah. What's left over is a dirty bin. We need to clean this up. So I'll ask Riaan just to show me how to clean it up. But this is so nice. M1 done.